The Indian Space Research Organization has achieved several milestones over 2 decades through its Chandrayaan programs. The Chandrayaan-1 was launched in 2008 to map the moon's surface and collect data. It helped discover water ice in the moon's polar regions. Chandrayaan-2 was launched in 2019. It included a landing experiment and orbital experiments to map the moon's surface, collect high-resolution photos, and measure solar radiation. The landing experiment included vikramlander and pragyanrover, but due to loss of contact, the landing was not accomplished. Chandrayaan-3 is scheduled to launch in July this year. Its objective is to achieve landing on the moon and conduct experiments on its surface. The mission consists of a propulsion module and a lander module, together known as the integrated module. The propulsion module is a box-like structure which consists of the propulsion system to take the lander towards the moon in its intended orbit. It will also carry and conduct an experiment known as SHAPE to help discover habitable exoplanets. The lander module consists of experiments to be conducted at the moon's surface along with a rover. Its objective is to land softly on the surface of the moon with the help of its propulsion system and various sensors, altimeters, and hazard avoidance cameras. The propulsion system includes 4 bipropellant engines running on monomethyl hydrazine and mixed oxides of nitrogen. The lander has 4 experiments on board. Radio anatomy for moon-bound hypersensitive ionosphere and atmosphere to measure near-surface plasma density. Chandra's surface thermophysical experiment to measure thermal properties. Instrument for lunar seismic activity to measure seismic activity. And laser retroreflector array to understand the dynamics of moon system. The lander would deploy the rover on the surface by reclining the ramp. The rover is a 6-wheel drive assembly connected to 2 navigational cameras, a 50-watt solar panel, 2 experiments, and communicates with the lander via antennas. The experiments include laser-induced breakdown spectroscopy for elemental analysis and alpha particle X-ray spectrometer to determine the composition of lunar soil and rocks. Chandrayaan-3 will launch from Sriharikota using an LVM-3 rocket and enter an elliptical parking orbit around Earth. The propulsion module will then guide it towards the moon and into an orbit. It will lower its orbit to 30 kilometers before separating from the lander. The lander will then perform a soft landing on the moon's surface. The Indian Chandrayaan missions, along with global space scientists, were able to discover traces of water ice on moon's south pole, making it an important site to be observed and analyzed. Chandrayaan-3 will analyze lunar seismic activity, soil composition, and various other properties of lunar system at the south pole. This will help us learn more about the lunar system and assess the habitability of lunar bases and potential settlement locations.